In this video, we'll do some chain rule examples that involve applying the rule more than once. So the first example says, let b of x be equal to e to the cosine of 7x over 2, and I want to find the derivative. So first I want to make an observation about this. I see a fraction, but I don't have to do quotient rule on this. If I can see that the 2 is a constant, and I could rewrite this as a 1/2 in front of e to the cosine of 7x, and now when I do the derivative of this, the 1/2 can just stay in front, and then I'll multiply the 1/2 by whatever the derivative of e to the cosine is. Alright, so as review, remember that the derivative of e to the x is just itself. It's just e to the x. What we're after now is, how do we find the derivative of e to the something more complicated, e to the stuff? Okay, so to do this, let's identify what our outside function is and what our inside function is, because it turns out this is a composition of functions. So what is our outside function and our inside function? So when I have an exponential, I plug in stuff into the exponent. So in this case, it's the stuff that's getting plugged in. So the inside function is this stuff. So maybe let me write g of x is the inside function, and it's the stuff. And what it's getting plugged into is e to the x. That is my outside function. F of x is e to the x. Because if I verify this now, and I write f of g of x, I have to plug g of x, which is the stuff, into f of x. So wherever the x is, I have to plug this stuff in, and that gives me e to the stuff. And that's my function. It's e to the stuff. So I do have a composition of functions. Okay. So the chain rule is going to say, well, take the derivative of the outside, and when you do, keep writing g of x in. Sorry, keep plugging g of x into it. So don't plug in x, plug in g of x. So the derivative of my outside function is e to the x, is just e to the x. Let me put it in gray actually. Except the chain rule, the way it starts, it doesn't say write f prime of x. It doesn't say do f prime of x. It says, oh, keep writing g of x. Keep writing whatever that stuff is, the inside function. So I would have to do e to the stuff rather than e to the x, and I multiply by g prime of x, the derivative of the inside. So in this case, it's going to be the derivative of that stuff that I plug in. Okay, and that is how we're going to find the derivative of e to the stuff using chain rule. It's just going to be e to the stuff times the derivative of that stuff. All right, so I want to put a box around this. This is showing how we can apply chain rule to handle e to the stuff. All right, so let's use this for our example. So for the derivative of our function b of x, the 1/2, we can keep it out in front because it's a constant multiplying our function. And we'll multiply that by the derivative of e to this stuff. So chain rule says we'll do the derivative of the outside first, which is the e to the whatever part. And that's usually e to the whatever. Okay, but instead of writing x, I have to write g of x. I have to write that inside function, which in this case is cosine of 7x. And then the chain rule says, okay, well then multiply by the derivative of the stuff. The derivative of cosine 7x. So in other words, I used e to the stuff times the derivative of that stuff. All right, so we have, let me write b prime of x here. B prime of x equals 1/2 e to the cosine of 7x. And now for the derivative of cosine of 7x, we need, this is, let's put this in red. This is chain rule again. This is chain rule again. Because I'm not just plugging x into cosine, I'm plugging in some stuff, 7x. So chain rule says, okay, first take the derivative of the outside thing, which is negative sine. I'll leave some space. And then it says, when you do the derivative of the outside, don't just plug in x, plug in the same inside thing, which is 7x. And then it says, okay, Now multiply that by the derivative of the inside, the derivative of 7x. All right, so we get b prime of x equals 1/2 e to the cosine of 7x. This whole thing, and then times, well, let's see. I think it would be simpler if I just move the negative all the way to the front. So negative, and then let's see, we have sine of 7x, and then times the derivative of 7x, which is 7. And that is my derivative. All right, so we successfully took the derivative of e to some stuff. And this involved doing the derivative, using the chain rule twice. So let's look at another example. All right, so example 3, our function is c of t. It equals this square root of 4t squared plus the cube root of 6t minus the fourth root of t. So a bunch of roots inside of each other. And I want to find the derivative. So I'm going to give you an opportunity to practice this first. Try this for 3 minutes on your own. 4, 3, 2, 1. Pause it and try this for 3 minutes on your own. With chain rule especially, we really just got to practice it and get more comfortable with it. Don't be afraid to make mistakes. Alrighty, so hopefully you did that. Hopefully you paused it and tried this for about 3 minutes. So for this one as well, I'm going to identify my outside function and my inside function. So my inside function, eventually, I will just be able to tell what these are, and I'll just dive right into the chain rule without explicitly writing them every single time. Okay, so it's going to be helpful. We've seen before with roots that it's helpful to rewrite them as powers when I take derivatives. So the big old square root is going to be a big old 1/2 power. Inside I have 4t squared, and then I have a big old cube root, which is a 1/3 power. And inside of that we'll have 6t minus a fourth root, so that's going to be t to the 1/4. Okay, so my inside function is going to be everything that is getting plugged into this 1/2 power. So I'll write g of t, because my variable is t, is 4t squared plus 6t minus t to the 1/4, that quantity being raised to the 1/3. Okay, so that is my inside function. And my outside function, what that whole thing is getting plugged into is this sort of like 1/2 power function. It's t to the 1/2, or it's square root of t. Okay, so let's get into chain rule. So when we do the derivative of this thing, okay, first we have to write the f prime of g of t part. So f prime means we'll take the derivative of the outside thing, which will mean bring the power rule. So 1/2 comes down. I'm going to leave myself some space, subtract 1 from the power, and I get minus 1/2. But I don't just write t here, because the chain rule says, well, on the inside, we write g of t. So I have to write the inside stuff. Okay, so the inside stuff, which is 4t squared plus 6t minus t. Let me give myself some more room. T to the 1/4 to the 1/3. So that whole thing is to the negative 1/2. But then it says, well, multiply by the derivative of that inside stuff. So we multiply by the derivative of the inside function, g prime of t. So in our problem, that inside stuff is 4t squared plus 6t minus t to the 1/4, this quantity being raised to the 1/3 power. Okay, so we've gotten it started. Now we got to think about how we take the derivative of this stuff. Well, 4t squared, that's not bad. That's just power rule. That derivative is going to be 8t. For this whole thing to the 1/3, notice it's not just t to the 1/3. It's some more complicated stuff to the 1/3. So that is going to require the chain rule. So here we go again with the chain rule. All right, so I'm continuing on to the next page to give myself more room, but we were here. So, okay, I'm writing my derivative. The first part stays the same, 1/2, and then 4t squared plus, parentheses, 6t minus t to the 1/4, close that parentheses, to the 1/3. That whole thing to the negative 1/2. That stays as it is. But now we're going to multiply this by, first, the derivative of 4t squared, that is 8t. And then we need the chain rule on this stuff to this 1/3 power. So first I deal with the outside part, which is that power. Power comes down. And then I subtract 1 from the power to get a negative 2/3. And when we do that, we don't just write t here, because the chain rule says, well, keep plugging the same inside function in. And the inside function for this part of the chain rule is this. It's the 6t minus t to the 1/4. And that's going to get multiplied by its derivative, so the derivative of the inside thing, which I'm just going to go ahead and do. I'm not going to write ddt of it and then do it in the next step. I'm just going to do the derivative of this inside thing. So the derivative of 6t is 6. And then for the next term, I'll get minus 1/4 t to the negative 3/4 when I do the power rule. All right, and now I can close this bracket that I opened. I can close that. Okay, one important thing that I want to comment about this is notice that this term is only multiplying this. It's not multiplying the 8t, because the 8t came from the derivative of 4t squared. So the things that are multiplying each other came from whatever term I took the chain rule, I applied the chain rule to. And that was just this 6t minus t to the 1/4 to the 1/3. And those are the things that popped out of that chain rule. They are multiplying each other. Alrighty, so that is our answer. So in terms of our goals, we've continued to do goal 1, applying the chain rule, but we've started goal 2, which is recognizing when and how we apply the chain rule more than one time.